Hi, everybody. Sorry again for being out today. I'm going to continue with where we left off yesterday. We finished segment addition postulate yesterday. We're moving on to angles now with the second part. So we're going to start with the protractor postulate, very similar to the ruler postulate that you saw yesterday. Basically, given array BA, which you can see there on the protractor at 0, and a point C not on BA, we can assign a number basically to the ray that goes through um, point C. So 0 is assigned to the horizontal line, so BA is 0, and 180 is BD on the other side, and then BC is assigned to the 60. So you could say that this angle ABC is 60 degrees, measures that angle. Okay. Go ahead and clear that out of the way. So do a couple practices with these. What is the measure of angle BEC? So I'm going to go ahead and mark this up a little bit. BEC, if you start at B, go to E and C, that is this angle right here. Okay, so can't really do much with that right now. Um, what I do see is that I've got angle AEB is 47 degrees. I also see that the angle that goes from 0 all the way to C, so that whole thing so it's called AEC, is actually 105 degrees. So I can use that information and say that 47 plus X equals 105. Subtract, and I can get X equals, what is that, 52? Uh, yeah, 105 minus 47. Get my calculator here real quick. Yeah, 58. I said 52. Besides that. Okay. So that is the angle BEC. You can, oops, minimize that. You can see the solution worked out here. So there you go. We'll look at one more, or I guess two more here. What is the measure of AEC? Well, we actually just looked at that. That was 110. Or no, it wasn't. It was 105. Sorry, 105. Okay. What is the measure of BED? So now I'm looking at the angle BED. There's a couple ways of doing it, but what I'm going to do here is I'm going to say I know this one's 47. I know this one's X, and I know AED, the whole thing from here all the way to here is 130. So I know 47 plus X equals 130. And you can subtract and figure out that um, it's 83. So, okay. So we're piecing together, kind of like we did with segment addition postulate, we're piecing together parts of angles to figure out the whole thing, or the missing pieces, I guess. And that's actually what I just showed you is angle addition postulate. If point D is in the interior of angle ABC, and you can see that with the picture on the left here, right there, then the measure of ABD, this one right here, plus the measure of DBC, which is this one right here, equals the measure of ABC, so the whole thing. All right. And you can see that if I drag these around on the picture, the red is the individual angles and the blue is the full angle, so ABD. So if I move C around, the 60 doesn't change, but the red numbers change. But they always add to 60. It's only when it's on the interior of the angle, though. So if I move it out here, it doesn't work. Okay. All right, so that's angle addition postulate. We're going to practice that now. So a lighting designer is finalizing the lighting plan for an upcoming production. The spotlight can rotate 25 degrees to the left or right from the center. The beam of light from the spotlight forms a 22-degree angle. Can the designer use the spotlight to light each of the objects on the stage? So we redrew it. with the angles a little bit more clearly labeled there. We've got the chair on the left. The rug is pretty much straight up from the vertex, the door, and the table. So you can see X and Y in that picture. All right. It says to compute that, um, X plus 22. So, geez, different color here. X plus the 22, which is right here, equals the 57, which is right there. Subtract, you get X equals 35. And then you can look at the Y plus 57, which is right here, equals the whole thing, which is 74. So you can use that to find Y. You get Y equals 17. Now, what does that mean for this problem? Well, the light can only go 22 degrees. So the spotlight can only go 25 degrees to the right or left. So the designer will be able to light up the one on the right, which was what was that? The table, I think. Yeah. But will not be able to reach the chair. They would need a larger spotlight. It was an application of the angle addition postulate. All right, so last thing to look at is congruent segments and congruent angles. This is pretty simple. It's just a little bit of a marking thing and understand what those markings mean. So segments that have the same length are congruent segments. So you can see there A, B, and CD. It shows little markings on it right here and right here. Those are congruent markings or tick marks. That shows that those two have the same length. Same thing with P, Q, and RS. They use two ticks because it's not the same as A, B, and CD. They're different lengths, but they are the same as each other. P, Q, and RS are the same length. So they are congruent. Angles, we use arc marks. So they're little, you may have seen them in previous problems. That means those are the same measure. If there's two, and there's one that matches with two, those are the same measure as well. Okay, that's what those mean. So how can we use that in problems? Well, let's look at an example here. All right. I would recommend pausing. See if you can, if you felt like you understood that, try to figure this answer out. Pause it, maybe copy the diagram down in your notes, give it a shot, and then watch as I go through it. Okay. So it's saying if the measure of XWZ is 127. So XWZ is the whole angle there. From here all the way to here. It's 127. I got 32 degrees for XWY, but there's those arc markings. So this is also 32. We're looking for YWV, so we're looking for this right here. So hopefully you can see that if I add 32 plus X plus 32, I will get 127. So X plus 64 equals 127. And now I'm just going to subtract 127 minus 64, 63. So X equals, or angle YWV equals 63. You can see it right there. Here's another one. Different, I'm asking for the length of HF. So HF is down there at the bottom, and it's made up of two different segments. I'm going to add those together. Think segment addition postulate. Well, what are the lengths of those segments? Well, the double tick mark here and here means those two are equal, so that's 11. And the single tick mark here and here and here mean those are all 8. So 8 and 8. So HF is 11 plus 8, or 19. And it'd be centimeters here. Okay. Oops. Couple more. Again, pause and try it. This is a little bit different. So I'm telling you the NOP is 31. And NOQ, so the whole thing is 114. What is ROQ? So we'll put an X there. ROQ is that angle. Well, the ROP has the arc markings, so it's also X, so the same thing. So x plus x, or 2x, plus 31 equals 114. You can solve that for x. I'll do that pretty quickly here. And once you get x, you've actually found ROQ. So 114 minus 31 is 83. Divide by 2, you get 41.5. So ROQ is 41.5. All right, go ahead and clear that. Last one of these. This one's a little trickier than the one we just did a couple examples ago. Suppose CD is 11.5. I'm going to go ahead and label that. So CD, actually, you know what? Make it a little bigger so I can see it. 11.5 CD. DE is 5.3. And the perimeter of the figure is 73.8. So the whole thing around the outside is 73.8. Well, I'm going to fill in the missing pieces as much as I can. So the tick marks is what we're looking at. Again, HG is 11. GF and EF are both 8. Well, now I can use my idea that the perimeter is 73.8, and I can just add up all the sides. So we're missing this side here. We'll call that X. And we're just going to go around the figure. 8, 11.5, 5.3, 8 and 8 again, 11 and 11. And so now we're just going to start subtracting things. Minus 8, minus 11.5, minus 5.3, minus 8, 8, minus 11, minus 11. And I actually get 11 for X. Now, how does that help me? Because I'm looking for GE. Well, if I'm looking at this a little closely here, 3 tick marks, 3 tick marks, those are equal. So I can say that this is 11 as well. So 11 centimeters. Okay. And that concludes this lesson. Hopefully that helps. Be ready for your quiz tomorrow. It's a short quiz, and bring any questions you might have with you to class. So we'll hopefully see you tomorrow.